All right, so we'll look at metathesis reactions here. Usually you're looking at two or more ionic compounds or just ions. And the goal is to find favorable ion combination. And the way we determine what a favorable ion combination is by looking at what precipitates. So do you guys have the solubility rules memorized? Do you have to do that in 1A? Yeah, okay. Gas formers. What are the gas formers?
Unstable.
Yeah, unstable products like
Ammonia.
H2CO3, like carbonic acid, decomposes into water and CO2, etc. We go from stronger acids to weaker acids. Do you guys have the 7 strong acids memorized? If so, then you treat most everything else as weak. We have other types that don't involve ions. And the other type that don't involve ions are with ammonia or ammonia-like compounds. Ammonia is just NH3, but ammonia-like are an organic class of compounds called the amines, and they all behave like ammonia because it turns out that hydrogen and carbon have roughly the same electronegativity. And so if you replace one of these hydrogens with something called methyl group, do you guys remember methyl group? CH3. If you replace it with a CH3 and get methylamine, then the electronic characteristics around nitrogen stay fairly similar to what it is in ammonia, and it's going to behave pretty much the same. And so methylamine, dimethylamine, trimethylamine, ethylamine, probylamine, all those behave like ammonia. What about like trifluoroamine? Would that behave like? No, because fluorine and carbon and hydrogen are quite different. And so if you replace it with a fluorine, then the characteristics of it totally change and it doesn't behave like you'd expect. And so the amines, ammonia-like, this is like ammonia-like compounds are called the amines, also participate in metathesis reactions because ammonia and the amines are weak bases which partially hydrolyze water to form hydroxide and ammonium. And so the ammonium ions and the hydroxide ions can participate in metathesis reactions. And so just a review of the solubility rules, you can fill out this table yourself at home. Here's the acid chart. You can read this. We can get the ranking for the weak acids. And so most people have the strong acid memorized, but the weak acids, you just look it up in the chart. We're going to do a lab this semester where we're going to look at what makes one weak acid stronger than another weak acid. Now, that's going to come later. But right now it's just kind of, here are some other things for gas formation. We talked about carbonic. The other ones I was looking for, sulfurous acid, ammonium hydroxide, hydrogen sulfide, hydrogen cyanide. These don't decompose. These just form straight gases. Hydrogen cyanide is very dangerous, obviously. And so you would never want to mix like a strong acid with a cyanide containing compound, otherwise you can generate hydrogen cyanide gas. If we ever do generate toxic gases, we do that in the hood so we don't poison ourselves. One of the toxic gases that we do generate in Chem 1B is hydrogen sulfide. This is a toxic gas, and the good thing about this gas is you can detect it to the part per billion level with your nose. And so your nose is a very sensitive detector. The problem with your nose is it soon becomes saturated and desensitized to hydrogen sulfide. And so you could be inhaling the stuff and not realizing it. And so the minute we detect hydrogen sulfide, we'll either evacuate or best yet, we shouldn't detect any hydrogen sulfide. If you're very careful with lab technique and you do the things in the hood, I don't know how many times it says do in hood, and somebody's doing it on the lab bench. And do they want to poison themselves? Maybe. It's chemical risk. Anyway, let's try metabolism. Everybody, let's try this. Calcium carbonate with a with sulfuric acid. Try this one out to refresh your memory. And let's see if I have some paper.